Okay, so we have this beam, no? We have solved this by the slope deflection equation. So this is my first example using the slope deflection equation. Now the same beam, we will solve this by moment distribution method. Okay, so the steps that we are going to use by MDM or moment distribution method are the following, no? So first, we solve for the fixed end moments, and then we determine the stiffness factor, then the distribution factor, and then you have to balance the moment and then distribute, and then the carryover moment, and then repeat the pod na balance, distribute, carry over, then balance, distribute, carry over until such time that the moments are almost negligible. Okay, so anak nakamuundang sa balance nga step, no? Then you sum up the moments at that end. Okay, so here we have already determined the fixed end moment. So mao man ni ang atong gi-compute sa una by SDE. So you have a concentrated load on member AB, fixed at A, and then fixed also at C, and a roller at B. So the 25 kilonewton concentrated load is acting at the midspan. So solving for the fixed end moment, it is PL over 8. So minus 18.75 because counterclockwise man siya dire. And then clockwise at B, so we have 18.75. And for member BC, WL squared over 12. So we have negative 20, and clockwise at C, so positive 20. Next, we solve for the relative stiffness. So what is the relative stiffness for KAB? Okay, so atong gamiton relative na laman, no? Relative stiffness, which is K equal to I over L. So for KAB, so I is not given, it is a constant EI. Okay, so we have I over the length of AB is 6. Okay, and for KBA, excuse me, so this is KAB, which is also equal to KBA. Okay, so para sa mga sila member AB, member BA, maura. So ang KBC, which is also equal to KCB, is I, what is the length of member BC? 4. Now, so that we'll have whole numbers of the value of the stiffness factor, we will find a common multiple of this magnitude here, no, of the stiffness. Okay, now sa may common multiple sa 6 ug 4, diba 12? So if we multiply this by 12 over I, and this one also 12 over I, we are not altering the meaning of this magnitude because ang atong multiply parehas man. So proportionate gihapon sila, no? So if we simplify this, this is equal to 12 over 6, so that is 2, so makancel man ni. And this one, 12 over 4 is equal to 3. Okay, so we have here a table para di ta maglisod pag balance, distribute, and carry over. Okay, so for KAB equal to KBA, so atong K is 2 and BA is 2, and then for KBC we have 3 and 3. So sa may distribution factor, it is equal to K over summation of K, no? So at joint A, so mao ni atong table, so we have the first row joint, so pila ka joints ni A, B, C. Okay, A, B, C. And member, at joint A, ang nag-connect ang member is AB. So manang AB. At joint B, ang nag-connect ani nga mga members BA and BC. So mao nang BA and BC. At joint C, you have only members CB. Okay. So the distribution factor for AB, now according to the procedure, if the support is a fixed end moment, fixed support, the distribution factor for a fixed end is equal to 0. So kani si Ja will be 0 ka fixed end man. Okay. So for BA, so ang iyang distribution factor is ang iyang K over summation sa K sa duha ka member, so that is 2 over 5. So this is equal to 0.4, no? And for BC, 3 over 5 or equal to 0.6. And since at C, fixed support gihapon, so this is equal to 0. Okay, so we place the fixed end moments for AB, minus 18.75, for BA, positive 18.75, for BC, minus 20, and for CB, positive 20. Okay, so mo-balance ta, no? Okay, kung mo-balance ta, ang imong moment times the distribution factor. Now, fixed support man ni si Ja, so ang imong distribution factor is 0. So, kanipod, mas 0. Okay, so pare sa example na to ganina ba sa joint. Okay, nga ang imong moment i-resist kani. So, ang imong i-resist ani is equal to the distribution factor times the moment. So, bale, mao ni ang moment at joint A. No? So, times the distribution factor which is 0. So, 0 po ni. Okay? So, on member BA, na kay duha ka moments nag-act 18.75 minus 20. So, sa to pa positive man ni negative, so opposite ang ilang direction. Okay? So, kung opposite ang direction, imo na siyang i-minus, no? So, 20 minus 20 plus 18.75, that is equal to laman, negative 1.25. Okay, so ang ilang balance nilang duha is negative 1.25. So, kung negative 1.25 ang moment nga naa sa joint, i-resist na siya og pila man sa BA, pila pod sa BC. So, sa ato pa, times sa distribution factor. So, ang balance nila, duha ka moments nga nag-meet sa joint B, times the distribution factor, mo na ang moment nga i-resist sa BA. Okay, di ba? Negative ba ni? So, ang i-resist niya will be positive para equilibrium. So, minus 1.25 minus nino. So, puros positive ang imong i-resist, no? Pares ganina sa atong example nga kani. Sa ato pa, negative ni kay counter. Nya, kaning ni-resist kay clockwise man, so positive. So, maoro po na nga principle dire, no? Okay? So, kani si Ja, naakay mga moment nga positive o minus sa joint. So, ang iyang balance is minus 1.25. So, ang i-resist sa member BA will be opposite in sign. So, that would be 1.25 times 0.4. That would be equal to 0.5. So, i-calculate ninyo, that is 0.5. So, 1.25 times 0.4, that is 0.5. And then, 1.25 times 0.6, that would be 0.75. Okay? So, this one here, sa fixed support, 20 times 0, so that would be 0. Okay, so after balancing, we carry over moment. Okay, so sa derivation, so kung naay moment sa pikas nga end, i-carry over na siya nito sa pikas, the same direction, but 1/2 the value. Okay, so ang AB will give to BA and BA will give to AB. So, what is 1/2 of 0.5? So, that is positive 0.25. So, this one 0. So, 0 po ni. Okay. Now, this one be carried to CB and this to BC. Okay, so this will be equal to 0, and this one positive 0.375, 1/2 of 0.75. Okay, so repeat na pod, balance. Okay, balance. So kani times 0 will give you 0. Okay, so what naman kay moment dire nga unbalanced nga moment. So this will be 0, 0, and then kani pod 0. So what na kay distribute, balance, and carry over. So i-add ni mo ni from the fixed end moment. I-sum up ni mo nita ng moments nga naa dinhi. So that will be minus 18.5. And then at BA, that is 19.25. And for BC, minus 19.25. And for CB is 20.375. Okay, so if you look at our example last time by the slope reflection method, okay, so ano yung atong na-solve, no? Na? Okay, diba? That is 20.375 for BC and 19.25. Sa AB, mao ni, no? Para man to. Kare. No? So, mana 18.5 is a pikas pod 19.25. So, positive man, so clockwise, and sa AB, counterclockwise because it is negative 18.5. Now, after determining the moments at the joints, so you can proceed to determining the reactions, which I already explained in STE, and then you can draw the shear and moment diagram. Okay, so thank you.